Hello Anand, how are you? Am I audible? Anand, am I audible? Hello? Okay, hi. Let's wait till 6:10. Generally, at that time, more people join. So, just let me quickly write the agenda for today's session. So, first we will solve week 12 as we might not get time later in the weeks because this is the last session. So, the deadline might be far away, but you might be having some doubts. So, I will try to solve not exactly the question but the concepts behind it, so that will help you in solving the question. I should have taken this week 12 session, say a week later or something, or like 2 3 days after, like from yesterday. But anyways, and then we will revise all assignments and concepts of previous weeks. So let's wait for some time, let some more people join. So till now we have the attendance of 3. Generally the attendance is around 10 11 10 11. So let's wait for at least 5 people more to join, then we'll start. Hello. It will be uploaded. It will be uploaded by the end of this week, hopefully. Why are people not joining today? I told yesterday itself, right? Anyways, I will post an announcement here, okay? Just in case. Sorry. Yeah, it has happened to me like not only this, yeah. So it decreases exponentially. 100, 42, 26, 21, 17, 12, 10, 11, 30, 10, 11, 11, 10, 10, 4. And that too, it was going beyond 100. The limit was 100, that's why only 100 people were there. So if, yeah, it happens in, like I have been doing TA for like multiple courses, and in all the courses I'm facing the same thing. Anyways, let's start. I cannot wait anymore. We have a lot of stuff to do. I might need to go for a break to drink water because I don't have my bottle today with me. I'm sitting in the lab. So we will take a short break around 7 p.m. or something. And let's start by first solving week 12. I think I discussed some of physics inspired neural networks, etc. etc. So I don't have the answers. I might get something wrong because these are the topics which are philosophically quite relevant to me, but I haven't seen the videos. So anyways, let's solve it. Let's, if not able to solve, we'll solve using GPT. And let's see what analytical approaches we can follow to solve such questions. Which is the key advantage of surrogate models over conventional high fidelity models? Require less compute time, easier, capture all physics phenomena, require less computational time. This will be the correct answer as per me. I haven't studied anything, I don't know. Which is more appropriate to use physics informed neural networks? Somebody has joined. Praveen, mute. Oh, sorry, I haven't shared my screen. Sorry. Let me share my screen. So yesterday we had, good evening Praveen, in Delhi it was like quite a strong storm and my lab's windows are broken. So some noise might come from outside. Apologies for that. So am I audible, right? And this screen is visible. Okay. So Praveen is the 5th student today. So last class we solved these types of questions, and I will ask you people to solve this. When we should use physics informed neural network over traditional numerical methods? Which of the answers? Yes. So when the data is limited, when the equations are non-linear, very complex, then we use PINN. Okay, so right now all the options suggest otherwise. Only this option matches somewhat to the representation of, like, definition of PINN. What is included in PINN loss function? The combined error? Yes. Praveen, are you sitting near some, what should I say, water? Okay. Yeah, okay, no problem. I thought it was some water pump which we use in farms and agricultural land type of thing. Quite familiar sound. So this will be the correct answer as per me. I don't know, you guys study and solve it. I mean, it combines the errors. Both errors are combined. If we open last week, let me open last week's. Sure. Just type. Yes, just type whatever doubts you have, and like you can unmute yourself, but keep it minimum. I have my earphones on, so it disturbs me. It, like, pinches my ears. There's something. Let me show you. Yeah, it was here, this paper. So one is that mean square error of your data. The other is mean square error of the equation residual. Okay, so the both things are combined together. So it is a combined error from data fitting, that is your data, label data, and the residual equation residual. What technique? Automatic differentiation. Yesterday we already saw that. Which neural network is typically employed for standard PINN? So this question yesterday, I think someone asked me. I think it was Deepu. I think you were the one who asked. Yeah. So you asked na, why use FNNs? Why not use CNNs? Why should not we use RNNs? Okay. So I said na, if you can use CNNs, you can use RNNs. But the thing is, you have to model the equations accordingly. The equations of ENN are already in the simplest form, and you can simply modify those equations to model physics informed neural network. So it's easier to use ENN compared to CNN, because CNN is not simply uh, product multiplication. It is like striding, padding, and everything. And physics does not use those concepts easily. Like you can, but in physics it's not easy to implement those concepts. So that's why CNNs are not used generally. So it's always feed forward for neural networks with hidden layers. Okay. So similarly, your answer will be the same, NN with 3 inputs, X, Y, Z, and as many hidden layers and we want. Okay. So these two questions are basically related to each other. Yeah, this one. In context of PIN solving time-dependent PDE. Now that your PDE is time-dependent. So this one should be the correct answer. Time cannot be handled discretely. Let me ask ChatGPT. So anyways, I think the answer is either converted to Fourier transform like we do in physics. Somebody asked something. Okay, are you sure? Yeah, so generally it's okay. Let me check. Okay, cool. Somebody joined, somebody typed something. Okay. Prabhu joined, I think. Prabhu will be joining. Yes. Yes, Praveen. So if you take time as additional axis like we can do in case of CNN as well. So this is handled by adding like this. Which of the key challenges of PNN, which of the following describes key challenge when implementing PINN for complex fluid dynamics? I think boundary condition should be the problem in fluid dynamics. What should be the answer? Okay. So where's that? Yeah, this one. So why is it so? I don't know, like I'm asking you. Hello? You don't know? Okay. 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 I mean, you saw the video. It's the answer is given there, right? Okay. So try solving this question. Go through the video. This computational fluid dynamics and the description and solution. You might find the answer there, because as I told, I haven't seen this week's lecture, and these 4 weeks I have studied earlier, so this is very difficult for me. I mean, not difficult. I don't know, like unaware of these exact concepts taught here. When using neural network to solve Bulger's equation with PIN approach, what could be necessary to compute accurate solutions near stock formation? I don't know. Still, I mean, again, I don't know. Okay, so which is true? PINs trained with physics constraint often generalize better than, yeah, this one. This one should be the correct answer. So this is week 12, end of week 12. And now you guys are ready to give exam. So yeah, so like if you want to ask some particular doubts about some week or some topics you want, I can uh, like solve those doubts first, and then we can go and revise assignments. So whatever suits, just tell me. If you have any doubts, just let me know. If you want me to solve assignments first, I can solve anything. Okay, I will give that idea. I mean, okay. So let me just open that right pad again. Sorry, right pad online. This was this one. Okay, it's a nice. So, oh, internet issue. Audible? Actually, this happens a lot in IT. Like internet keeps on breaking. I don't know. National Level Institute and this thing happens. So, anyways, I will start. Let me increase thickness. Thickness. Yep, this looks nice. So let me go step by step from neural network and everything. Now suppose you have say 200 features here, and this is your y-axis. So what you do is you create a neural network here. You pass all 200 features here. So input dimension is 200 cross something, whatever neurons are here. So at initial level there will be 200 cross whatever neurons. Say assume there are 4 neurons here. So at initial level there will be 200 cross 4, that is 800 weights. Okay. Then similarly again, and so ultimately you finally should have one weight that predicts your y. And if you have multiple labels, then you can add a softmax classifier and correspondingly those many weights. So you train it using loss function and backprop. This is backprop. One by one, let me ask from last to first. Praveen, how do you implement backpropagation? Am I audible, Praveen? Guys, am I audible? Okay, so Deepu, you tell me, how do you implement backprop? Arey, no. That is in PINN, that is different thing. Don't confuse that thing with this thing. I'm not teaching PINN, I'm teaching normal neural network. Arey, just tell me that intuition, how do you implement it? What do you differentiate? What is minima? What is maxima? That stuff. I don't need one word answer. I need an explanation. Okay, leave it. Assume, assume you have just one feature corresponding, you assume you have one feature x, corresponding weight is w. Okay, w gives you output y, for which loss L is computed. So L versus W plot is plotted, and for one weight the plot is obviously a parabola if you use mean square error, because square parabola, equation of parabola is a square function. Okay, so your loss is minimum here. Okay, so whatever weight here is, you will have to use that. So how do you determine that weight? At this weight the loss is zero, loss is minimum, means that this is point of inflection or like minima, maxima, whatever it is. So at this point delta L or slope of L is 0. So you can simply write this equation. You can write delta L divided dou L by dou W. Wherever it is 0, you have to find W there. Okay, easy peasy. But maths like this thing is not deterministic. In maths you cannot solve it if you don't know the function. Like you don't know the exact function. Okay, no problem, Praveen. If you don't know the function, because the function right now is some wx plus c equals 0, and this x is changing. Do not have the value of x, do not have value of w, because loss this graph you can only compute when you have all the values. So okay, so what you do is at whatever loss you have, you find slope and you subtract it from w. So w new is equals to w old minus slope. So when slope is negative, you subtract from w. This means that this thing is added to w0, wo. So when something is added to wo, w goes from this side to this side. So assume you are there, you are here. So once assume your slope is positive. So in that case, you subtract. Why is it positive? Because this theta is less than 90, this theta is greater than 90, so it's negative, it's positive. Okay, basic maths. So if you subtract w from here, your weight will reduce. You're subtracting, you're not adding anything. So once the weight reduces to this, so you come this side. Okay, so ultimately you do it multiple times till you see that your wn is almost equal to w0 or wo. Okay, so this is how you compute. So if you have like two features, then this parabola becomes 3D parabola, like a tent shape, something like that. If you have like 4 features, 3 features, something like that, so it keeps on increasing in dimension. So if you start adding too many features and too many complicated neural network architectures, it does not remain a simple parabola. It becomes a composite parabola, composite function, f of g of x of h of blah 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 blah. In that case, there will not be just one minima. There will be a lot of minimas, a lot of local minimas, and one global minima. To reach that global minima in neural network, to reach that global minima, what we do is in neural network we try to initialize weights. Okay, so these weights are initialized using something, so that our curve becomes somewhat. Our curve becomes so right now the curve might be something like this. You have one minima here, then peak, then one global minima, then then here peak, it goes again a global minima, then something, then some saddle point, then something, not, it won't go back, it will go forward here. Okay, so then again some minima. So if you are stuck here somewhere, because the slope is 0, your weight won't change, you will not be able to come here or here. So in that case, you have to remove these things. So these things are generally removed when you initialize the weights well. So in the assume your weights are initialized randomly, so these randomnesses will come. Okay, but you initialize weights from same distribution. So assume this is one set, this is one set of weights, this is one set of weights. So ultimately they will be combined like this. So this randomness will not come here. So there will be a lot of minimas, but they all will be approximately to same depth. So that's why we use Hay or Normal or Xavier Glorot initializations. I think it's not visible, right? I think I have zoomed a lot. Yeah, this should be fine. So assume you have this one, these many weights. So if you combine them, it will be like, if it's a linear combination, it may become one big depth-wise weight. These will be removed. Or like if you convolute one over them. So this is one, this is two. So it will become a giant minima or some combinations of minima, but they will be similar. With approximately, like, this will be point of inflection, but it will not be that much peak. It will not have these many inflections. So to avoid that, like, so that these things, like, to basically get this type of curve, we use Hay, Xavier Glorot, etc. type of initializations. This is your neural network. Okay. Then there are multiple optimization techniques. Sorry, where's the board? Such as Adam W, RMS prop. These techniques basically help you in jumping from these inflection points. Okay. In jumping from these inflection points or saddle points, okay. So yeah, this is how you solve neural network problem. Any doubts till now? Any doubts? Yeah, sure. So this is your neural network, okay? So now you had data something, where's data? I lost data. You have a neural network like this. Sorry, data like this. So actually your normal neural network can also handle your images, okay? If you can just flatten the images, if this image is, say, assume this image is 494096 cross 4096, okay? If you flatten this, it becomes 10 raised to power 8 features image with some class label y1, y2, y3. The problem is that the spatial information is lost. Okay, somehow this pixel, so assume this pixel was dependent on this pixel. So now these two pixels are very much apart. So this information is lost, because in normal neural network, if you jumble these rows, these columns, it's fine for for all data points if you jumble it. But here, if you jumble it, you will lose information. So this is why we do not use these normal neural networks. We use convolution neural networks. In that case, we just pass this whole image in this convolution filter. This convolution filter runs on this whole image to give an output image something like this, reduced form something. Okay, so this filter tries to extract information from this image by pixel intensity and etc things. Okay, so what is the problem with this thing? Can anyone tell me? Deepu? Praveen? Okay, so the question was, if I'm passing image even like this, even like the whole image in a CNN, what is the problem with this thing? Can you tell, Deepu? What shall I tell? No, I mean that can be solved. No, I can reduce the size. I can do whatever I want. And like CNNs can handle large images as well. There's nothing, no problem with that. So what is the another big problem with CNNs? Like a normal neural network, CNN can only handle fixed size image. So in normal neural network, whenever you collect data, you have data for every feature in the network, correct? In the data sheet or data network, you have to like, if there is nothing, you just write NaN. But in neural network, the images are of different sizes. Sizes means the different aspect ratios, different number of pixels, 4096, 1024, something like that. How do you handle that in CNNs? Deep. No, no, no. If you're splitting it again, you are losing that spatial correlation information, right? So if the image is larger, okay, if the image is larger, so you can either crop it in the sense you can drop the boundaries, because the boundaries generally don't have relevant information. The image has been captured such that the information is centered around the center of the image, or you can reduce the size of the image. Okay. So any of the two things you can do. Third thing is, if assume no problem. If you assume you have say width is same, length, height is different, so you pad that image. So if the image is smaller, you can pad the image. So the padding is very important operation, because after applying convolution filter, the size of image reduces. So if you have a very large convolution filter, okay, the size will reduce a lot. So in that case, we pad the image. We pad the image by 3 pixels at all margins, 2 pixels at all margins, something like that, 100 pixels. So once we pad the image, the reduced size image is not that much small. So that is what padding is. Okay, that is what convolution is. Okay. Any doubts? Deepu, any doubts? So I was saying that if the image has small size, you pad the image. If the image has different dimension, you crop it or you pad it. So padding is very important operation. Padding also helps to retain the size of original image after applying convolution filter. Okay. So this is basics of CNN. Another thing is stride. So stride is how much you jump. Let me zoom in here. This is nice. Yeah. So I will tell you, okay, this is 4x4 pic image, okay. This is your 4x4 image. You have a convolution filter of size 3x3. You have a convolution filter of size 3x3. Okay. So what you do, you basically map this convolution filter of 3x3 over this image. Okay. And whatever output you get, you add it, you multiply. Basically, it's a convolution operation. So this pixel into this pixel, this pixel into this pixel, this pixel into this pixel, and you add it. So whatever value you add or average it, whatever you want, whatever value you get as one block here. Then since the stride is 1, assume the stride is 1, I skip it by 1 block. So now new convolution block is this one. So this one will be the new convolution block. It will give me another output here. Okay. So now the width has been traversed. I will go down here. Okay, so I will take eraser, I will erase it, erase it, erase it, erase it, erase it. Yeah, so these three blocks have been covered. This block I will take down now, these three blocks. This will give me another set of value here. Then I will take these three blocks. Okay, so what did we get? We got a 4 cross 4 image. From 4 cross 4 image we got a 2 cross 2 image. We lost a lot of information by applying this convolution filter. Correct, Deepu? So if we had we added padding here, we could have increased the size to 3 cross 3 or 4 cross 4, whatever we wanted. Okay, so generally the formula for that is image size formula for CNN. So there is some nice formula. Yeah, you can see my screen, right? So see, this is first convolution, then you skip stride is 1, then stride is 1 here, then stride is 1, stride is 1. So ultimately you apply this filter, and for this value you get something. Okay, so there's some very nice formula. There's a very nice, yeah, this one. So yeah, this one. Width, height, same formula are there. So basically original width minus k. K is the dimension of filter. Filter is 3 cross 3. So width is 4 minus 3 plus padding is 0 initially divided by stride. Stride was 1. 4 minus 3 is 1 by 1. 1 by 1 is 1. 1 plus 1 here, 1 is 2. So the output is 2. The output is, where is it? Output is 2. Similarly for width and height. Okay. So this is how you compute the size of this block. If you add padding, assume I add padding of 1 block. So if you add padding of 1 block on height, you have to pad adding of 1 block here. Then you have to add padding of 1 block here as well. So that is why we add 2p. So that is W minus K plus 2p. Why 2p? 1p for this, 1p for this, divided by stride. Okay. Is this clear? Okay. So this is your convolution. This is your basics of convolution. I'm not going into depth of it. I'm clearing the screen now. How do we clear this screen? Okay, so any doubts till now? Okay, so now let's go to RNN. Okay. There's a nice blog on RNNs. Kola's blog. Let me. Am I audible, Deepu? Okay, so see, if you go through this blog, it will teach you RNNs. Okay. So you have this one block, which learns everything. So you take a sequence of data. Why sequence? So let me show you. So earlier you had this tabular data. Tabular data had fixed number of columns and rows were as many as high. Image data had a lot of rows and there was spatial dependency. This block was dependent on this block. Now comes your, I would say, text data or sequential data. Sequential data is like this. So one block is dependent on next, is dependent on next. This keeps on happening. Okay, it's not like something jumping forward, backward. Just like in case of CNNs, it's like this. This block is dependent like this. This block is dependent in backwards fashion. This block is dependent on this. This block is dependent on this. This block is dependent. So it means that you have to pass and learn these informations individually and separately. So what you do, assume this is block 1, this is block 2, this is block 3, this is block 4. You take an embedding of block 1, you pass through, you learn some weights here, W. Okay, you compute the output. Assume this is the output 2 cap. Okay, and you try to match it with 2. If this 2 cap is equals to 2, your weights are learned properly. Fine? Fine, Deepu? Okay. Next step you do is, once you have done with that, then at next time step, what you do, you take block number 2 and assume the answer is 3 cap. You try, if you check if the answer is closer to 3, you update the weights till the answer is closer to 3 and then you delete this thing. Then you come to block 3. So you pass 3 here, it gets output 4 and keep on doing it. So this is what it's telling. It's telling that you keep on repeating this whole thing again and again. So at you pass x0, you get h0, you pass x1, you get h1, you pass x2, you get h2, you pass xt, you get ht, and this is how you do and solve RNNs. Okay? So for LSTM and all, you can just go and see the blog, this nice standard blog. If I'll teach, it will take a lot of time. That time is the only thing which we have limited today. You should also visit these blogs, representation, etc. These are very nice blogs. Attention. This one is also good. Convolution network, a modular perspective. So this one is a nice blog if you want to basically study CNNs in, I would say, proper in-depth knowledge of CNNs. Okay. So this is all about RNNs, CNNs, LSTMs, basic information. So any other thing you want to ask? Didn't get it. Okay. Yes. I am understanding, no problem. There's a saying, right? There's a saying in Hindi and I think multiple languages that you can choose your friends, but you cannot choose your neighbors. So you can request them, but you cannot just change your house. So it keeps on happening. Even I face some issues. My neighbors are my relatives, so you can also not choose your relatives. You are born with them. So that is another issue. So anything else you guys want to discuss, or shall we just briefly go through the assignments and topics you should study? Huh? So there is vanishing gradient is, your gradient is 0. Gradient means that derivative of the loss function is 0. Okay. So if it is 0, ultimately you have achieved minima. This means that you have achieved minima in case of a normal machine learning problem. But in case of deep neural networks, if gradient is 0, it might mean that you are stuck somewhere. The gradient is vanishing. And this is because since you apply chain rule, so in between some weights gradient was 0 for some weight, and that is propagated back to you. Okay. So to handle gradient, this vanishing gradient problem, these problems are generally seen in case of RNNs or very deep neural networks. So if you have like a very deep neural network, what you do is you try to reduce the size of the network. Okay, first of all, RNNs have this vanishing gradient problem. In that case, what you do, you basically try to use LSTMs. Okay, so in that case, you pass more information from back to forward, so that the gradients generally do not vanish easily. Okay. In case of CNNs also, it's generally due because of the size of kernel. If you just remove all data, if you take a very big kernel, and the image will become very small. Internet. Hello, audible? Yeah. So if you take a very big kernel in CNN, again this whole thing will just vanish because the information is lost. So try to take smaller kernels. Okay. So these are all the techniques which you do to basically solve this vanishing gradient problem. Exploding gradients are that like the slope is very big, infinite, or the slope is greater than the weight. If your slope is greater than the weight, assume your weight is 0.5 or like 2.5 and slope is 12. So you subtract 12, like you multiply it by 0.1, assume your slope is 120. You subtract 12 from that, and now your weight is -7. So that has basically shifted the whole weight. This is basically the gradients are exploding for you. Okay, the gradients are very high. In that case, you have to reduce the gradient. How do you reduce the gradient? Optimize the loss function. You take these weights, like these standard weights, like normal weights, Glorot, Xavier Glorot, all this stuff. In that case, it's not difficult. It becomes like the distribution of loss function becomes uniform, and your gradients do not explode. Okay. So if you're taking some random weights, say first weight is 1, the other weight is 2000, in that case gradients will explode for sure. Okay. So these are the techniques, general techniques which you use for gradient minimization. So to solve the problem of zero gradient or very high gradient. Any other doubts? Hello? Okay, so these are the issues with gradient and all. Let's just go through all assignments and see what topics. So you can just, like you can see the topics from here itself. So linear independence, this is very important. Okay, so try to solve these questions. If the matrix is linearly independent or not, if the features are, it's a full rank matrix or not, these questions will come. Full rank of matrix is equals to the column number of columns. If the columns are dependent, determinant is 0. These all questions will come and you will have to solve them. Okay, so this is the only topic important from this week. Normalization and norms are also important, but this one is very important. Probability, Bayes theorem. Okay, Bayes theorem, conditional probability, total probability, chain rule, independent condition. These all things are important in this week, right? Conditional probability, to solve conditional probability, B given A, you have to solve, 99% you will have to solve the probability of A given B. And to solve the probability of A given B, you will have to solve this equation. Probability of A given B, which is probability of A intersection B divided by probability of B. Then probability of B will be the probability of B into probability of, that will be probability of B given A, B given C, something like that. So you will have to solve one conditional probability divided by total probability to get another conditional probability. So that this question will come. Okay. So this is only important thing here. Expectation covariance. What? Okay. So Bayes theorem, I'll just give you an example. So suppose you're in a very dark room, and you are in a very dark room. I place a bucket in front of you. That bucket has 3 red balls, 2 black balls. I ask you to pick a ball. And what is the probability that it will be a black ball? It will be number of black balls by total number of balls, correct? Okay. Though the other thing is the dependency rule of probability. So if I place 2 buckets there, okay, and then I ask you, what is the probability of picking a black ball? So you don't know which bucket you are putting your hand into. So the probability of choosing the bucket is 1 by 2. The probability of picking the ball from each bucket will be something. So assume that is first one is 3 by 5, second one is 2 by 5. Okay, correct? So what you do is you apply that total probability rule. So suppose you picked bucket 1, so probability of picking and then what is the probability that you will pick a black ball? So as that will be Bayes theorem. So Bayes theorem will be probability of picking black ball such that bucket 1 has been picked. That will be your 1 by 2 into 3 by 5. What is the probability? I'm not showing screen. No, I'm just showing on my hand. Okay. So the other it will also be 1 by 2 into 2 by 5. So that will be 5 by 5, 2 by 5, whatever it is. So that will be 5 by 5 into 1 by 2. So that will be 1 by 2. So probability will be half of picking a black ball. So you took the conditional probability, you added it to get total probability. So now question will come, suppose you have picked a black ball. What is the probability that the ball came from bucket 1? Then you will have to apply what I just told. You will solve the probability of black ball given bucket 1. You will try to solve it in inverse way. You will try to solve it. Basically, if you write it, the probability of A given B is equals to probability of B given A and something in denominator. So how is it derived? Probability of A given B is equals to probability of A intersection B divided by probability of B. Okay, and probability of B given A is probability of A intersection B divided by probability of A. So basically you multiply those A given B, B given A. So this is your basically your multiplication. So A by B into B and B by A into A is equals to intersection. Okay, so if you have to solve one thing, you will have to use another thing. So this is what I'm saying. This is what you have to do. Okay. 99% questions of probability are around this topic only. This is very confusing topic. So people generally get confused, otherwise it's the same. Okay, so coming to week 3. Week 3. So week 3 is about optimization. So this is Hessian matrix, Jacobian matrix, Taylor series. You can just watch the video, you will get to know. Matrix calculus is very important topic. You also should watch it. So in this week, these constrained and non-constrained optimization. So unconstrained and constrained optimization, and these 4-5 topics are very important. Okay, coming to week 4. Week 4 is the topic where this linear regression and these concepts come, the goodness of fit, the R square value, bias variance trade-off, the overfit versus underfit problem. Okay, so these all things are here, and these all things you need to study. So any doubts here you want me to teach you or tell you or clear the doubts. Deepu? Deepu, can you tell me what is bias and what is variance? No, just, yeah, you explain me. What is bias and what is variance? Given a data set, given a model, what is bias, what is variance? Given a classification data set and a model. Got it? The question. Yes, Praveen. Arey, don't give me definition. Don't give me definition. Give me an example. What is bias? What is variance? So where's the bias? Okay, so what is bias in this case? Well, if the athlete is performing and not performing, how will you define or basically picturize or yeah? Okay. Okay. Okay, so let me explain. Okay. So assume you have a data set. Okay. So whatever you train a model, the data set has 4 classes. And whatever input I give to the model outputs only one class. So model is biased towards one class. Okay. This is the problem when you undertrain a model. Undertrain means your weights are not optimized, your weights only lead to one output. Now assume you have 4 classes and data is distributed perfectly, but you tweak the data set a little bit. You change one parameter, one feature by some very small factor and the output changes like that. Okay, so this means that the boundary is very much overfitted on data and a small fluctuation just shifts the input from one boundary to another boundary. So that is variance. So that means you have overtrained the model. The model line is not smooth, it is very haphazard and it is basically touching the data points. That should not happen. Touching the noise. So if you introduce noise in your data and the output changes, exactly. So bias is when your training error is high and validation error is high. Your variance is your training error is low, but your validation error is high. Let me draw a graph and you have to choose something in between. Yes. Yes, correct. So this is your validation error. This is your train error. So this is the initial stage of training. So at this stage, the train error is high, this validation error is high, this is bias. In this stage, the train error is low, validation error is high, this is variance. And here you can see train error and validation error are quite low. This is trade-off. Don't overtrain your model, don't undertrain your model. This is the whole point of bias variance trade-off. Got it? Then gradient descent and all I just showed you. Compute loss function, subtract the derivative, that's all. Then logistic regression is again that thing. So your linear equation has some equation mx plus c. You apply sigmoid function over it to convert it to probability. This becomes the probability. And you train the model such that the probability is 1 for good data and 0 for bad data. And there you get logistic regression. So multinomial is, again, you know, if there are multiple features. Okay, so just watch the video, you will be able to solve it. Okay, week 6 CNN just taught you. Watch these things, so these videos, this 1, 2, 3, 4, 5, because the questions might come from these videos and they are not conceptual questions, they are just rectification questions. You have to mug up the architecture and etc. Coming to week 7, segmentation and all, just watch segmentation, watch dice ratio. This I already told. So these 2 things are important here. 2, 3 things. Week 8 is very important. BPTT is very important, backpropagation through time. Okay. So in normal neural network, you backpropagate on same data, and so your backpropagation is, this loss function remains constant. Okay. But in BPTT, at each time interval, loss function changes. Each time interval, loss function changes because your weights are updating. Okay. So yeah, that is BPTT. It's basically applied in RNNs and LSTMs. Week 9 is your KNN bagging boosting. I already told what is bagging, what is boosting. Already told you. This thing is very important. Just study bagging. Why? How do we split the data? If you go to this week 10 solution or week 10 video lectures, you will find it. Like how do we compute bagging, boosting, etc. And what is the need? Like how the bagging problem solves overfitting problem and boosting solves underfitting problem. So underfitting is what? Undertraining. So you overtrain the model on losses. Overfitting means overfitting. So you basically split the data and train models for each feature separately. So that's also a problem. Then there is week 10, probability distribution, Gaussian support vector machine. A lot of things are here. I mean, the syllabus is very less, but the topics are very important. So here you should study the central limit theorem and support vector machines. They are very important here. And this doesn't mean you should not study other things, but they should keep focus on this. So GAN, VAE, these 2 things are very important here. This thing I already taught you. So if you want to study, you can. Otherwise, you can skip it. Not very important. MLE and MAP is also important. Week 12, I already told this physics part. This application. These all applications are important and questions will come. At least 2, 3 questions will come from week 12. So for 3 marks, you should study it, I would say. Any doubts? Okay, so Murli has left. He said like he will be asking doubts in email, no problem. So I think that will be all. Like this is the whole syllabus, and I don't think so. Like, what happened? Yeah, so this is the whole syllabus, and I don't think the syllabus is difficult. Is it difficult? It's like if you are studying it for first time, you might need to push yourself a bit. Otherwise, syllabus is comparatively average for machine learning course. What do you say, Praveen? Which one? Okay, so I will share some lectures. You can just watch these lectures for CNN. Exactly, obviously, like RNNs cannot be finished in 1 week. Okay. No, I don't think so. There will be any questions regarding coding. So you don't have to worry about coding and all. Uh, yeah, but you actually you can go through these videos. He is my supervisor. Yes, so actually this course is on NPTEL also. This thing, large language models introduction. If you search it, you will find it. So you should go through these two videos. Nice videos, and you will just get to know what is LSTM, what is RNNs. Like from basic. Try watching it, try understanding it. And for a CNNs, I don't think so we teach CNNs. But for an NLP part, we teach everything. So next semester we are planning to upload machine learning course as well. Let's see if it's possible to like record it. But anyways, hope for the best. Yeah, I'm working on NLP and graphs. NLP, yeah, it's yeah, yes. You guys also wish you all the best, and I hope you would have enjoyed these sessions. 13 weeks, because I see generally the doubt sessions for like other students, other scholars who take doubt sessions, they basically restrict themselves to course curriculum. And I also, I mean, I try to restrict myself to course curriculum, but this is like the topics are very vast, and you need to. If I'm looking down, it is because generally my monitor is in front of me and my laptop is kept overhead. But right now I'm sitting in lab, so my monitor is here. So my habit is to look in front. Okay. So it's not like I'm avoiding the camera, just my habit, force of habit. Okay. So generally I try to teach. Correct. I mean, if I do not conduct these live sessions, there's no harm to you. You can just solve the assignments yourself, search Google and solve it. Exactly. I mean, to an extent, I teach, like I solve assignments for you, that is fine. But I try to teach something different. I try to teach same thing differently. See, if you watch videos, last week's 2, 3 weeks videos, you will see that, say, I taught some concepts like the GANs and some stuff from beginning and in completely different perspective from professor, so that you can develop an intuition. So my teaching style is theory you can learn from a lot of sources, like books are there, etc. But for beginners, machine learning is very difficult from theoretical perspective. So if they are taught the intuition perspective, then they can map theory to it. So any topic, whenever you try to learn it, first you learn the intuition behind it, then you try to write the theory behind it. So that makes the whole thing complete. So I try to do the first part, the intuition part, because like this is beginner level course. It becomes difficult if I just stick to the theoretical concepts. I would have taught you very easily that's maximum likelihood what is that minimum likelihood expectation and all. I could have taught machine learning using those concepts. I could have taught SVM using multiple concepts like what is kernel, what is all, and that would have been not beneficial to you. But I taught SVMs like you take the whole data, you create a convex hull around it, then you take bisect that whole the line, perpendicular line. That is how you get the perfect plane. Okay, I taught how to compute the distance of point from line. So these are all intuition based things, and once you get the intuition, the theory is not very difficult. Okay, not everyone is a student of maths. Exactly, the machines are also learning. Why should humans not learn? So Exactly. It's a semester-wide course. Like it starts in January, ends in April. It's very semester-wide course. Exactly. Week one, week two, you can skip because I like these are very basic things, and I already taught you like just from my mouth itself right now how to solve the question. So you can skip week one, week two, week three. You can like give it a medium importance. Week four you should give above medium importance, and week five you can again give medium importance. But week six should be given a particularly high importance. Okay, and week eight should be your highest priority. Week eight and week 8 and 9, sorry, 7, 8, 9 should be your highest priority. That CNN, yeah, no, not week 7, week 8 and week 9. Okay? Yeah. You can skip week 12 if you want. Week 12, like, I think you just watch the videos and it will be the recent one, so it will not be an issue. So week 12, the questions will be like, as I already told you, the questions will be around what is, why use PINN? What is the, like, to solve complex problem, to solve nonlinear problems, what are two things, equation residual and your data residual, these two things. So this is all about week 12. Okay? So you can skip week 12 as well. So, but these 7, 8, 9, they're very important. 10, 10 is actually good. This SVM part is good. PCA part, I think PCA is easy. PCA is easy, but SVM is good. You should study SVM. Okay, and apart from that, week 4, I think we left week 4. We skipped week 4. No, we didn't. We skipped week 5. So week 5, study this thing: one hot vector. What is one hot vector? What is softmax? What is back propagation? Already I told you, but study this and try to solve this by when you study this, take a pen in hand and write down. So that way you will learn more. Okay. I think that is all. That is all. Like the course is not heavy, but the exam is still 15 days away from today. So if you give like an hour a day to this course is more than sufficient. Yes, CNN architecture is important. Like if somebody asks you what is Alex, how many layers are in AlexNet, so just try to remember it. So these architectures are important. Like some questions might be asked, some basic questions like how does InceptionNet solve the problem of vanishing gradient and very high number of parameters. So that is only you can understand if you watch the videos of InceptionNet. Okay, so these lectures are important. I already told you. Yes. Yes. ResNet you can skip. ResNet is like you basically create a residual connection from like from previous layers, like older layers to new layers. Yes, you employ skip connections. You take this block diagram, you skip connection here to here, so that when the gradient is 0, where gradients are vanishing, you basically pass data from here to here. So now gradients here are not vanishing. So that is all about ResNet. Okay. Exactly. Okay, but these things you should study: LNet, AlexNet, VGNet, GoogleNet, DenseNet. DenseNet is your completely fully connected neural network. Okay, so DenseNet is nothing. DenseNet is your just fully connected neural network. So you can also skip that. So just these 3 topics are important. So first AlexNet came, then VGNet came, then GoogleNet came. So what problem they were solving from the previous architecture, that is you have to study. Let me show you one thing. So if you see DenseNet, okay. So DenseNet is completely dense network. All layers are connected to all layers. Okay. So it is like fully connected graph. Thanks, Praveen. Thanks for nice remarks. And please fill the feedback form. And anyways, it's not important to me. That's just NPTEL team asks you to fill it. So you can fill it if you want. Okay, so yeah, this is all about these networks, neural networks, CNNs. The problem is, from next year onwards, what I'm planning to do is, I'm planning to conduct these doubt sessions in completely different way. Like, it's see, like many people join this course. Just a second. Yeah, am I audible? Hello. Yeah. So many people join this course because they have an exam to pass. In colleges, they have the grades to submit. So I agree, they cannot invest more time to learning a lot of things because like course is very heavy and some people have priorities. But my basically my loyalty lies towards those people only because NPTEL pays me to do that only, to solve doubts of those people. So assignment solving is mandatory for me. I have to solve the assignments for previous weeks and previous years if available. Okay, so that basically helps us a lot. Actually, it also helps me to get to know the concepts and what has been taught to you. So I try to remove that, but it's like inevitable. I cannot remove assignment solving. So apart from that, I try to teach. But the thing is, like today now 3 people have joined and you guys are interacting. Last year, people were not joining, and 1 or 2 people joined and they were just completely mute. Arey. Yeah. So hello. Yeah. So last year, people joined and it was very difficult because people didn't join. 1, 2 people joined and they were not speaking, so interaction was not there. So I just solved the assignments and I left. Like it was not headache for me. Like I can leave anytime. After 1 hour, my duty is over, so I can leave. Like I don't have to interact with you. But like this year, I really enjoyed, like because you guys are interacting, you guys are enjoying the course, and it will help. It helps me basically. It keeps me motivated as well because the next time if I'll take this course, I will know like these all things were taught and these all were the suggestions and these all topics were where you people were weak. So I will basically focus more on those topics from start. This was my first time taking this course as TA. So if I take this course next year also, so that will again help me. This interaction of us will help me to basically create better sort of teaching material for you. So every time, like it's also a learning experience for me, not just you. Yes, I'm doing PhD. Yes. Okay, so anything else you want to ask, or we can just exit and you guys can prepare for exam. My mail ID is already there, na? sahilmr32@gmail.com. I email a lot. Please join. Live session is going on. I keep on emailing this. So from this email ID, you can email me here. If I don't reply, just send me a reminder next day. 24-hour reminders. So because sometimes I skip the mails, I'll get a lot of mails. So if I skip it, so you can email me after 24 hours and I will reply. Okay. A lot. That's what. See, I'm today in my lab. I'm taking session from lab, not from my room. So I'm that busy. I was planning to go to my room, but some work came up and it was already 5:55. So I thought I should take session from here itself. So it becomes difficult. But ultimately, like I enjoy teaching. In BTech also, I used to teach programming and machine learning. So I enjoy teaching. That's why I'm sitting here. Some people generally take this is computer science. So like some people take this is my part of my PMRF TA duty. So some people take TA duty outside some other colleges where they don't have to teach. They do some falsifications. They get certificate. They do like bare minimum and get the certificate. But it feels like fraud to just know this much information and not share with anyone. So that feels like something you should give the community back. Because I was taught by someone. I am here because someone stood up and taught me something. And it's all also for you as well. So like you are here because someone stood up for you, someone taught you, someone just made you study. So if there are not YouTube videos, there's nothing like that. So if nobody teaches no one, then what's the use? What's the use of knowledge? I know, like those people are IIT Madras, so IIT Madras faculty, they're top notch. You cannot just debate about anything. Like this is number two, number three faculty. No, they are that whole faculty is top notch. Yes. Actually, I am part of some like curriculum designing and so this LLM course, the videos I shared here, those videos are gone. You might be able to find it. So let me just add it. LLM. What was that? RNM, LLM. Yeah. So you can like I'm pinning this, so you can just go through this playlist. This is playlist of large language model. I also want to thank NPTEL. Like otherwise, it's difficult. It's difficult for me. It's difficult for me to teach. Yeah, I mean, the people generally who are in IT Delhi, they go to TA duty in JNU, did Kendriya Vidyalaya and all. And some people are tied up with faculties so that they have to do bare minimum, check the copies and leave. So like it's like you're helping out a faculty. So that is your teaching. That is more like helping the professor. Here I am helping out students. That is more valuable, I feel. That is more valuable than just helping out teacher. Because I do TA duty in IIT. I help my professor. I've done a lot of stuff for my professor. But that is helping professor, not helping students at all. If I am not there, professor will do it that thing on by their own. I didn't do MTech. I did PhD after my BTech. I did my BTech from Triple IT DM Kurnool, Andhra Pradesh. If somebody is from Andhra Pradesh, they might know this place. Praveen, where are you from? Which place? Chennai? Andhra Pradesh is. Where are you from? That. Yeah, I know that border. Which which place? Which place? I know. I have been Chennai also. Nellore. Okay, you're from Nellore. Nellore. Okay. Yeah, that is on border. That is just Tamil Nadu border. Yeah. Actually, my college, this campus, when I joined the institute, so this college was opened in 2015. Okay, and its satellite campus was in Triple ITDM Kanchipuram, which is in Chennai. So when I joined in 2017, I did my BTech from 2017 to 2021. When I joined in 2017, I stayed 1 year in Chennai. So I've traveled a lot. I have traveled a lot of India, like a lot of places in India. So my college has been in two places, two cities, two states, and I have stayed in like five different hostels. Yes, 1 year I've studied in Kanchipuram. Then shifted to Kurnool. No, I didn't study in Triple IT Kanchipuram. The campus was of Triple IT Kurnool was in Triple IT Kanchipuram. It was like they were hosting us. So from 2015 to 2018 they hosted us. From 2018 we moved to Kurnool. Yeah, design manufacturing. Yeah. So yeah, that's all about my journey. If you guys want to share your journey, you are most welcome to share. Praveen, where did? Yeah, hello. Yeah. Which assignment? Like, I asked them which assignment you want me to solve. Uh, I've already solved the assignment. The solutions are available here, and for the remaining from this week 9 to week 12, the solutions will be made available to you by this week. So you don't have to worry about it. Okay. And if you want me to solve some particular week, I will solve it. I think nothing, no problem with me. Okay. Let me open whiteboard. Yes. Control A, delete. Let me explain PCA first. Okay, PCA is easy. I mean, intuition wise. Sorry, let me SVM. Okay, so assume you have this data, this some random data here. So this data, this is just some data. This is of some class 1, and this you have this data here, which is of class 2. Okay, so your logistic regression is creating a boundary like this. This boundary is good, right? Logistic regression says that this is in going to class 2, this is going to class 1, sufficient. But is this boundary perfect? The boundary should have been somewhere here. Yeah, so boundary should be either this one or this one or this one. We don't know. So what we do is, in SVM, what we do is we take the data points outside data points, and we create a convex hull over them. Convex hull means some convex shape over them. No concave shape. Concave shape is something like this. This is a concave shape. This Ray-Ban glasses is a concave shape. Okay, because here this angle, this interior angle is greater than 90 degree. Okay, so the interior angle should not be greater than 90 degree. This would have been a convex shape. This is not. So interior angle is less than 90. So you create a convex hull here. You create a convex hull here. Convex shape can be of as many sides and edges. I created a 4-edge quadrilateral. So then what you do is take the nearest edges, the edges which are nearest to each other. So these edges are nearest to each other. Okay, you basically find say a perpendicular line connecting these edges. So it should be perpendicular here, it should be perpendicular here. Okay, visible? Then you have the length of this line. So assume this line is of length 12. So you have to bisect this line. So again, this bisector should also be perpendicular. This should be a perpendicular bisector here. Let me clear this thing. Okay, so you create a perpendicular bisector here. So this is your support vector margin, a machine. So these lines are called support vectors because this whole line relies on these support vectors. If we had chosen this line, the support line would have been different. Okay, so this is why it's called support vector machine, support vector margins. Why this vector? This is because it's not scalar, it's a direction. Okay, so this is also a vector. This is a line connecting these two vectors. These are perpendicular line here and here. Okay, so this is what support vector machine and support vectors are. So if someone asks you what are support vectors are those vectors which are closest to each other for two different classes on which the support vector line is drawn. Yes. Yeah. Yes. Okay, so now if you talk about PCA, so assume this data is, this is two-dimensional data, right? If I ask you to minimize dimension from 2 to 1, what could be the dimension where the data could be minimized? If I take just this dimension, is this data getting minimized? Which dimension is good? This one, or some other dimension? How do you determine it? So general rule of thumb is you take dimension where maximum variance is preserved. You maximize variance. Yes, yes, yes. This is PCA. Okay. So whenever your maximum variance is preserved, you have to check that direction. So you take this direction. You project all points on this line. Your variance is from here to here. Assume this length has 5. Okay. Then you take this dimension. This length is from here to here. This is 6. This is 5. But if you take this direction, okay, you take this direction, now your length is from here to here. This length is 8. Okay, so this looks like something like linear regression only. So what you do is you start from 0, you start from w equals to 0, you subtract something. Okay, what do you subtract? You subtract some weight from it. So in this case, you have to basically maximize it. Okay, so now equation is w new is equals to w old plus derivative. Okay, derivative of this function. This function is variance. Variance is a square function. Variance is power 2, right? So that is why it is an inverted parabola. Okay, so add some w. This assume this w is 45 degree. Okay, so at some w equals to 45 degree, your variance is maximum. At that place, your delta d equals to 0. This means that your w0 and wn are not changing. So at this place, maximum variance is there. Variance is x0 minus x mean whole square, something like this. Okay. So wherever this value is maximum, you take that value. And you don't need label data because your data is already there. You just need to find the maximum variance wherever it's preserved. So this is how you compute PCA. Intuitionally correct, mathematically also correct. There are other variants of PCA as well, but this is the most intuitional variant of PCA, which generally people tend to understand. Okay, so anything else? See, let me show you what eigenvalue, etc. Everything is PCA. Everything is just that concept of PCA. I lost, I think, the board. But no, it's not gone. Okay. So at this dimension, PCA is maximum, right? That variance is maximum. Okay. Okay. So this is 2D. So if I ask you, so in like your eigenvectors or eigenvectors, number of eigenvectors. What is this problem? Is always less than or equal to given dimensions, correct? Ultimately, the whatever you choose is always less than the given dimensions. So here, exactly. So this is where your maximum variance is preserved. Okay, you take something like this. Here, your second maximum variance is preserved. Okay, you take something like this again. Here, your third maximum variance is preserved. Sorry. What is the problem? Okay. So these are your three principal components where maximum is preserved. Similarly, it goes for eigenvectors as well. It's like somewhat different concept, but like doing the same thing. Okay. So yeah, that is all. And anything else you want to discuss, or shall we end? Amit has written something. Join this course for fun. So you're not taking exam, Amit. You're not taking exam, just watching this course for fun. I love those people who don't take exam and watch the course for fun. Because some people, like most of the people, just leave the course in between. If they are not taking exam, they just leave the course. Correct. Also, yeah. So also the obviously, ultimately the application should be known. Otherwise, the knowledge you don't know, like where if you don't know the application, you will never be able to learn the real meaning, like importance of that knowledge. Yeah, so like if you ask you the table of 13, if you say like what was the use of table of 13, now you will know. Whenever you try to compute something in your mind and if you know the table, it's very easy for you. It just saves time. These tables save time. It's not like this multiplication is gonna help you in getting an accountant job or something. These things save time. Some things always save time. Okay. So if I tell you you are traveling at 60 km ph and you have to cover 60 kilometers, so you will already obviously know you will cover that distance in 1 hour because you just know the formula. 1 kilometer per minute, you know that thing if you're driving at 60 km ph. So these all things help if you are traveling. Like some things are not just for mugging up. Like we asked now, what has school taught us? School has taught you things which will make your life easy. Not everything is about calculating taxes and all. So you can learn to calculate tax. It's not very difficult thing. If the school is only teaching you to calculate tax from first class itself, you will learn nothing else. Okay. There should be a holistic development of a person. It should not be just limited to something I would say just mathematical or scientific or accounting based reasoning. A holistic development is needed if the person also studies social sciences. So whenever a person sees something, it brings some experience, something he has been studying, or he gets to form that critical viewpoint of that thing. It's just not visual viewpoint. The critical viewpoint is formed when you study history, when you study social sciences. So every subject is important. It's not like that you should only study maths. Where is this maths coming in my use? Maths is coming in your use. You just don't know. If you had not studied maths, exactly. Exactly. So like there's a saying in product design. So the best design of a product is that design which you don't appreciate. It's that good that it's come into your hand so handy that you don't appreciate it. If you're appreciating something, that means that design is created just for getting appreciation, not simplicity. Okay, so maths and all these things we don't appreciate because we use them so often and so flawlessly that we don't even know. In our intuition, we use it. Like it's 12:15, I have to reach my hostel in 7 minutes, so that lunch will be over at 12:30. So will I be able to reach in time? So you all know that thing. So this is whole stuff. So this is all about machine learning as well. If you start studying machine learning just not for the purpose of passing the exam, if somebody asks you why study machine learning just because you have to pass the exam, no, it helps a lot in developing some concepts which might be useful when you go to professional life. Okay. Exactly. Exactly. So I like people who stay with me till this class 12 or class 13. It's very difficult for like my retention power is very low in retaining people till here, but still like 3, 4 people, 5 people, I'm more than happy. In see online you are just a number to me. Okay, just 3 people have joined, but in real times, assume that like 15 people appreciate you. That's why 15 people are coming to you. Just assume that whole human being coming to you and asking doubts. That is a lot. That is a big number. Even one person counts. If one person is coming to you, that the person is willing to learn something, the person is willing to share something. Okay, so now I would take the leave because I am thirsty, my throat is paining, and I'm also hungry. So it's my dinner time as well. My mess closes at 8:30, so I will have to leave. My hostel is far, as I already told, 8 minutes. Chalo then, all the best for your exam, whether it's on 27th or 28th, and just keep revising everything. If you have any doubt, just email there and tag me. tag me. If you will tag me, I will know that doubt is asked to me, so I will be able to solve it. Okay. Chalo then, bye bye, take care, and all the best for exam and future as well. Bye guys.